Okay, so right now we're going to dedicate some time to the right-hand side of our two-column proofs. The right-hand side of our two-column proofs are the reasons. And what we're going to do is we're going to write down all of the reasons that we have gotten so far that we can actually use in our two-column proofs. What is the very, very first reason that we are allowed to write down in a two-column proof? The given. You can always write down the givens. Okay, you are always allowed to write down a given in a two-column proof underneath the reason. So we're only talking about the reason side right now, okay?
We can just go up a little bit.
Sure, okay. The other thing that we can always write down on the right-hand side are properties. And we're going to abbreviate properties as P-R-O-P with a period. So we can write down properties, right? And give me an example of a property we could use as a reason. Addition property, give me another one. Substitution, give me another one. Subtraction. These are all properties that we can write down, okay? Another thing that we can write down underneath the reasons are postulates. Somebody give me a postulate that we could write down. The segment addition postulate, the angle addition postulate, the ruler postulate, right? These are all postulates that we're going to come up with a lot of them as we move through the course. These are the ones that we can always write down on the right-hand side.
What's the ruler postulate?
Basically, it says you can measure stuff with a ruler.
Okay.
What's after postulates? They get a little harder. Starts with a T. Theorems. We're allowed to write down theorems.
Does that make it like extremely hard?
No. Theorems, as long as they're approved, right? Proved legitimate theorems, we're allowed to write down a theorem as a reason. So, like, we could say, on the left-hand side, a statement could be, how about x squared equals a squared plus b squared? And that would be a Pythagorean theorem, or something like that. A theorem is we're allowed to write down on the right-hand side. We'll get to that as well. So theorems we can use. So we have givens, postulates, properties, theorems. We can also use definitions. Okay, and what do I mean by definition? As a little subcategory, right? I could have the definition of midpoint. I could use that as a reason. That's the definition of a midpoint. That could be a reason for a statement. The definition of maybe a segment bisector. That could be a reason. Another definition that we've had are angle bisectors. I could also use the definition of a right angle. I could also use the definition of a straight angle. So all of these, okay, so here's I have a picture for you. I have A, B, and C are points in the line segment AC, and here's the one piece of information you've been given. You've been given that B is the midpoint, okay? So what I have in that box there, I have line segment AB is congruent to line segment BC. And what I would like you to do is come up with what is the reason that would allow me to say line segment AB is congruent to line segment BC. It's got to be in what we've talked about. What do you think that reason is? Yes, Alessandro, what do you think?
The definition of it.
Yes, you are 100% correct. The reason that I could say this statement right here is because it is the definition of midpoint. Next little practice here. Here's the one piece of information that you've been given. You have been given that angle D is a right angle. So notice how angle D, as I'm talking about the physical angle D. And then notice that in my box here, this is a really important part. Notice that I have then the measure of angle D must be 90 degrees. So what reason would allow me to make the statement that the measure of angle D is 90 degrees? Nick, what do you think, dude?
The definition of a right angle.
You are 100% correct. This would be the definition of a right angle. Does that make sense, you guys? That's what allows me to make this statement. And do you remember, make sure you understand when we have the measure of angle D is 90 degrees, we're talking about the actual measurement, and we've just been given something about angle D. Angle D is a right angle, therefore the measure of angle D must be 90 degrees because the reason is that's the definition of a right angle. Does that make sense? We're building your geometry proof skills here. Okay? Here's the first one here. So all I've been given is a picture. That's all I've been given. And what's the one thing that we can assume based off the picture you see here? No. Don't worry about the box. Just look at the picture. All the lines are straight, and the rays are straight, and the points are on those lines or in those rays. Okay? So here's a statement I have made for you right now in the box. The statement I have made is line segment AB plus line segment BF equals line segment AF. Can someone give me the reason I'm allowed to make that statement? Justin, what do you think, buddy? You got it, my man. This is the segment addition postulate. Okay? If you want to do seg dot add dot post dot, that's cool with me too. Right? Because we have a lot of words to write. Segment addition postulate. Okay, here's another statement that I'm going to make about this particular drawing. And it's going to say this: the measure of angle ABE plus the measure of angle EBF is equal to 180 degrees. This is a statement I am making about this particular picture that you see here. What reason justifies that statement? Yes, Iman, what do you think? You are 100% right. That is the angle addition postulate. Awesome work, okay? And then the third statement I'm going to make about this particular thing is if B is the midpoint of AF, line segment AF, then line segment AB is congruent to line segment BF. Okay, that's a statement I've made about the picture. If B is the midpoint of AF, then we can say that AB is congruent to BF. What allows me to say that? What's the reason? The definition of midpoint. You got it. So that's a definition of midpoint.
Pretty much like anytime it says like midpoint.
All right, once we have the picture drawn, once we have our free points on the page, next thing we're going to do is we're going to mark up the text, or we're going to mark up the picture. So there is some information that we have been given, right? What have we been given? What do we know first? We know that ST and RN are equal. Okay, good. So we know that the two lines, the top line and the bottom line, those are the same thing. We know that. What else do we know? Okay, so here's what we can actually mark up, right? We know that this part right here is congruent to what part? Or is equal to what? RU, this part over here. Okay? And so what's the part that we're trying to show?
The SI and UN are equal.
We're trying to show that this highlighted segment and this highlighted segment are the same. First of all, do you believe that it's true?
Yes.
It sure looks like this should be true, right? So if that's the case, then we should be able to figure it out. Okay. Anybody have any thoughts of how we could start this? Okay. Now that we've done all this, now the hard part begins. We have to build the case that justifies what we're going to say. Jake, what do you think? What can we say?
Since they're both equal to RN, can't you set them equal to each other?
You're on.
No, it's
That's RU. It looks like an RN, but that's RU. Okay, but you're on the right track. All right. Yeah, this does not look like an RU. It says it right up there, right?
Well, because like you're like yeah, when you go like that, it kind of makes space.
All right, I'll try and write it in a little neither. Feel better? Okay. Any ideas? Thoughts? Yes. We know this. We know that ST is equal to SI plus IT. What allows you to say that?
Wait, how did you find out?
Okay, that's a great question. How do we find that out, right?
Oh, I got
It's the whole thing, right? The entire segment is the sum of the two little segments, right? Hey, could I say that same exact statement about the other line? What could I say?
They're the same lines.
RN,
plus UN.
there you go, is equal to RU plus UN. And what's the reason for saying both of these things, you guys?
Segment addition.
There you go. Segment addition postulate. That is the reason that allows us to do that. So then the very next line, since we know this, we can now say that SI plus IT has to be equal to RU plus UN. So what did we do there? We just had substitution. The substitution property. Very good. So it must be the case that SI equals UN because we already know that this piece of information, IT, and RU are what, you guys?
Same group.
They're equal because it says so right there. So therefore, I could subtract them from both sides, leaving me just with this piece and this piece, which, oh my gosh, is exactly what I'm supposed to show. And the reason behind it is subtraction. So here's our proof so far. Have you marked up the text or have you marked up the drawing? Okay, so tell me how you marked the drawing up. What did you do? Tell me what you did. How did you mark up the drawing? What did you do? What do you know?
Oh, on 1 and 2.
Yes.
Those lines, I did 1 dash.
The measure of angle 1 is equal to the measure of angle 2. So we're talking about an angle, right?
Yeah.
So that one and that one?
Yeah.
So a little dash there like that?
Yeah.
I agree with that. That's a great thing to do. Okay. What else can we do?
Yeah, 3 and 4.
How do you know 3 and 4? We're trying to prove that 3 and 4 are the same, right? The measure of angle 3 equals the measure of angle 4. Is that all you can do?
I think I got stuck.
Yeah. Wait. Is that actually right? Do we know?
Yeah, measure.
Awesome. The measure of angle 1 is equal to the measure of angle 3. Is there anything else we could say about this particular proof?
How do we know that?
And the measure of angle 2 is equal to what? And what is the reason that we can say this, everybody? That's the definition of what type of a bisector?
Angle.
Of an angle bisector.
And then measure angle 3 equal measure angle 4 by
Yeah, why does 3 equal 4 now?
substitution.
Exactly, because we already know that 1 and 2 are equal, right? So therefore, it must be the case that 3 and 4 are equal, and that is straight up substitution.